The turret lathe is a precision machine tool for performing a sequence of operations on duplicate parts. Several cutting tools can be mounted and preset on the hexagon turret. This turret is indexed to perform a sequence of operations on the same piece. Usually, such a sequence of operations begins with drilling. When the hole has been drilled, a boring tool is brought into cutting position. Finally, a facing cut is taken from a tool mounted in the square turret. Each tool change is made without stopping the machine. In addition to this advantage, several operations can be performed at the same time by combining cuts from the hexagon turret with cuts from the square turret, thereby reducing the machining time required for this work. A typical example of the work done on the turret lathe is the machining of workpieces such as this gear forging. To finish the piece, it must be drilled, bored, reamed, turned, and faced. The turret lathe is designed to produce pieces such as this in large quantities. These machining operations can also be performed on an engine lathe. On this machine, however, the tools must be changed or repositioned for each operation. For example, after a hole has been started, the center drill must be removed from the tailstock spindle. Then the twist drill is installed to open the hole. On the engine lathe, each cut is a separate operation, while on the turret lathe, several preset tools can cut at the same time. Turning and facing cuts are made from a single tool post on this machine. The tool must be set at a different position for each diameter to be turned. If the diameters vary, the cutting tool has to be repositioned. When a limited number of pieces are to be produced, it may be more efficient to do the work on an engine lathe, even though more time is required to finish each piece. Here, the larger diameter is turned with the same cutting tool as was used to turn the hub. An efficient turret lathe setup would have two cutters, one for each diameter. To complete the operations required on this piece, the turning cutter is removed from the tool post and a facing tool mounted. On this engine lathe, spindle speeds are changed for cuts of different diameters by shifting the speed change levers in the headstock of the machine. A similar arrangement for changing spindle speed is often used on the turret lathe. The headstock on both types of lathes has the same function, that of driving the work. Castings and forgings are held in a universal chuck mounted on the spindle. This machine is equipped with a power chuck. When the control handle is pulled out, the wrench is engaged. The movement of the chuck jaws is controlled by the handle. Because the three jaws move uniformly, this is called a universal chuck. When a workpiece is mounted in the chuck, the jaws tighten and the piece is centered automatically. The direction in which the chuck and spindle rotate is controlled by the clutch lever. When the lever is moved down, the headstock gears are engaged. The lever is moved right or left for reverse or forward spindle movement. Spindle speed is controlled by the pre-selector. Speeds are selected by rotating the hand wheel. When the clutch is engaged, the spindle rotates at the pre-selected speed. When the clutch lever is brought to the center position, it acts as a brake. The hexagon turret unit travels along the bed of the machine. It can be moved by means of the hand wheel, by rapid traverse, or it can be fed toward the spindle automatically. Several feeds are available. The hexagon turret can be clamped to the bed. The indexing mechanism of the turret lathe makes it possible to bring preset tools into cutting position quickly and accurately for performing a sequence of operations. The turret is held in place by a lock pin. Lowering the indexing lever drops the lock pin from the hole, allowing the turret to turn. The lock pin, which is spring-loaded, enters the hole in the turret when the lever is raised. There is a hole for positioning each face of the turret. Generally, first operations are internal cuts, such as drilling, boring, and reaming. When machining steel, a coolant is directed on the cutting edges of the tool to reduce temperatures and help wash chips from the work. The first step is to start drill the hole. The start drill cuts a tube cone to guide the twist drill. After start drilling, the hexagon turret is indexed to the next station, bringing the twist drill into position to open the hole. A high-speed steel drill is started into the work by means of the hand wheel. When it is cutting to size, the automatic feed can be engaged. After the hole has been drilled, the next internal operation is boring. Boring cuts are necessary to produce a true round hole concentric with the spindle. On this setup, no change of speed is necessary between the drilling and boring operations. Usually, the hole is sized and finished with a reamer. For reaming, the spindle speed must be reduced to about half the boring speed. This type of reamer must be guided into the hole because it is free to move in the tool holder. Being loose, the reamer floats through the hole, and all cutting edges remove the same amount of metal. Reaming completes the internal operation. External operations on this workpiece begin with turning the hub. The spindle speed can be increased when tungsten carbide tools are used. In making turning cuts, the tool moves parallel to the spindle to produce a straight, accurate diameter. Most turning is done from the hexagon turret, although some turning can be done from the square turret. Facing cuts are made from the square turret. The carriage moves the square turret parallel to the axis of the spindle. This side-hung type carriage has an extra lower way for added support. The cross slide moves at right angles to the spindle for making facing and other cross cuts. When the carriage is in position, it is clamped to the bed. The cut is made by feeding the cross slide. In making facing cuts, the tool travels at right angles to the spindle. Cross cuts of this kind are always taken from the square turret by clamping the carriage and feeding the cross slide. Automatic stops are available for each face of the turret. As the tool approaches the end of the cut, the stop disengages the power feed. When the cut is completed, clear the tool and index the next cutter into position. The outside diameter can be turned from the square turret station. Run the cross slide in for the required depth of cut. Now clamp the cross slide. For this cut, the carriage feed will be used. Turn the stop roll to the next position. This sets up the automatic stop for this tool. Shift the feed direction lever and engage the feed. The turning cutter, mounted in the square turret, is feeding parallel to the spindle. However, this type of cut is usually made from the hexagon turret. Two or more cutters can be mounted in any one hexagon turret station. Here, for example, a drill and two turning cutters are set up in a multiple turning head on one face. With this tool arrangement, both diameters are turned and the hole drilled all in one pass. While multiple longitudinal cuts are being made from the hex turret, facing cuts can be made from the square turret. This is called a combined cut. Here, 4 cuts are being taken at the same time. 2 turning cuts, facing, and drilling. With this setup, the turret lathe is being used to its best advantage. To review the turret lathe, the headstock has 2 functions: to hold and turn the work. Tools for drilling, boring, reaming, and turning are preset in the hexagon turret to perform a sequence of operations. Facing and other cross cuts are made from the square turret. Some turning cuts can also be made from the square turret. When cuts from the hex turret are combined with cuts from the square turret, the machine is used to its best advantage. Because the turret lathe makes it possible to perform a sequence of operations without stopping to change tools, it's an important precision machine tool for producing duplicate pieces in large quantities.